This video presents a shelf post-mounted frame designed for the Pimoroni Inky Impression 7.3-inch e-ink display. First, a quick overview of the frame, then a detailed review of the modeling process in FreeCAD 26.3 development build. This is a rigid two-piece frame that mounts onto the post of a standard 1-inch metal wire shelf. The e-ink display board is recessed into the front frame element and secured with M2 fasteners into threaded heat-set inserts. The rear frame element further secures the circuit board in place and provides half of the post clamp. The rear frame element is secured to the front with M3 fasteners into threaded heat-set inserts. Pipe clamps secure the rear frame element to the 1-inch post with M3 fasteners into heat-set inserts installed into the rear frame element. To model this frame in FreeCAD 26.3, first edit Preferences and enable Sketcher Preference. Always add external geometry as construction. This CAD model depends on a previously created CAD model for the e-ink display. Open the e-ink display model and then create a new document for the frame. Create a group for unattached sketches. Create a group for variable sets. Create a variable set for this document. Label it vars-frame. Create a link to the display board variable set. Label it vars-display. Create a new body for the frame's front element. Select the display board mechanical drawing sketch and create a subshape binder. Take a moment to add variable set parameters for use in the next sketch geometry. For single dimensions, use type property length. For multiple dimensions, use type property vector distance. Here I add PCB margin of type property length, PCB edge inner frame as property vector distance, and frame border as property vector distance. Create a sketch for the frame's front element. Use the external projection tool and select the outside edge of the display board. Verify the external geometry is added as construction. Create a rounded rectangle. Use horizontal distance and vertical distance constraints to fix upper left and lower right outside edges of the rectangle with variable set parameter front border X and Y. Choose one rounded corner and constrain the center of turn coincident with the reference geometry rounded corner. Remove redundant constraints as needed. Add another rounded rectangle. As before, constrain two corners of this inner rectangle with variable set parameter PCB edge inner frame X and Y. Choose one rounded corner and add a radius distance constraint. Pad the sketch with a length of variable set parameter front border point Z. Create a new sketch for the display board pocket. Use the external projection tool and select the outside edge of the display board. Create a rounded rectangle. Use horizontal distance and vertical distance constraints to fix lower left and upper right outside edges of the rectangle with variable set parameter PCB margin X and Y. Choose one rounded corner origin and constrain it coincident with the reference geometry rounded corner origin. Remove redundant constraints as needed. Pocket the sketch with linked variable set parameter vars-display point board point Z. Next, add variable set properties of type property length for the M2 heat set insert diameter and depth. Create a new sketch for the M2 insert hole pattern. Use the external projection tool and select the display board mounting holes. Create 4 circles coincident with the reference hole geometry. Select circle and apply distance constraint. Select the 4 circles and apply equals constraint. Pocket the sketch with length of front PCB insert depth. Create a new sketch for the M3 inserts hole pattern. Use the external projection tool and select the display board outside edges. Try a construction rectangle. Draw line segments from the midline of the construction rectangle extending beyond the reference geometry outline. Draw 6 circles, each coincident with a vertex on the new construction geometry. Select all circles and apply equal constraint. Select one circle and apply distance constraint on its diameter. Store the frame M3 insert diameter into the variable set. Apply horizontal and vertical distance constraints so the circles are positioned on the frame's front border midline. Pocket the sketch with the length of 6 mm and save it to the variable set as front M3 insert depth. Adjust the front element shape appearance with a body color and change transparency to 30%. Create a new body labeled back. Create a subshape binder to the front body initial pad feature labeled bind-front. Create a variable set parameter of type property vector distance labeled backborder. Set back border x and y equal to front border x and y respectively. Back border z equal to 3 mm. Select the binder face and pad it length of back border point z. Adjust the back element shape appearance with a body color and change transparency to 30%. Create a subshape binder to the front body's M3 inserts sketch. Create a new sketch on the XY plane. Use the external projection tool and select the bound sketches circle geometry. Draw 6 circles coincident with the external geometry. Select all circles and apply the equal constraint. Select one circle and apply a distance constraint of 3.1 mm. Save it to the variable set. Pocket the sketch. Create a sketch on the YZ plane for the frame's back element post-clamp feature. Offset the plane along its Z-axis so that it's flush with the frame's outer edge. Draw a rectangle. Constrain one edge of the rectangle coincident with the sketch Y-axis. Use horizontal and vertical distance constraints to set the width and height of the back clamp geometry. Use a horizontal distance constraint to set the distance from sketch origin. Pad the sketch. Create a new unattached sketch for the post hole pattern profile. It defaults to the XY plane. Draw 2 circles coincident with the x-axis, symmetric about the y-axis. Draw a construction line segment from each circle to the sketch origin. Select both line segments and apply equal constraint. Select one line segment and apply distance constraint. Select one circle and apply diameter distance constraint. Select both circles and apply equal constraint. Create a new unattached sketch for the post groove profile. Draw a rectangle coincident with the y-axis, symmetric about the x-axis, with the major dimension increasing along the x-axis. Draw a circle coincident with the x-axis, bisecting the minor rectangle dimension. Use the Split Edge tool, Coincident Constraint, Construction Geometry, and Trim Edge tool to remove excess material from the circle. Apply Radius Distance Constraint to the remaining half of the circle. Create a subshape binder to the groove profile. Translate the subshape binder placement such that it is coincident with the midpoint of the back clamp post feature. Apply groove to the groove profile binder and set the axis of rotation to the binder's y-axis edge. Create a subshape binder to the post clamp hole pattern sketch. Translate the binder placement such that it aligns symmetrically with the post clamp feature of the back body. Pocket the binder. Create a linear pattern and add tool shapes for the pad post clamp, the groove profile, and pocket hole pattern. Define the direction along y-axis, occurrences 2. Create a subshape binder to display board's mechanical drawing. Create a new sketch for through holes to the display board's mounting screws. Use external geometry projection and select the mounting holes of the display board. Create circles coincident with the reference external geometry. Select the circles and apply the equal constraint. Select a circle and apply a distance constraint. Pocket the sketch. Create a new sketch on the XY plane to define cutouts around switches on the display board. Draw a construction rectangle. Constrain the rectangle symmetric about the y-axis with the use of a construction point, symmetric constraint, and coincident constraint. Apply a vertical distance constraint to position the construction rectangle along the y-axis. Draw a rectangle relative to the construction geometry to define the cutout profile. Use horizontal and vertical distance constraints to fully constrain the sketch. Pocket the sketch. Create a linear array and add the pocket tool shape. Create a new sketch on the XY plane to define additional cutouts around features on the display board. Reference the mechanical drawing and physical display board. After fully constraining the sketch, apply pocket. Create a new body for the post clamp. Create a new unattached sketch on the XY plane. This sketch represents one half of the shape and will be mirrored later after padding. Draw two construction circles coincident with the sketch origin. Inner diameter equal to post clamp diameter. Outer diameter equal to post clamp diameter plus clamp thickness. Use line segments and arcs to draw the post clamp profile. Constrain the shape with coincident points and distance constraints with variable set parameters. Create a subshape binder to the groove profile. Rotate the groove profile 90 degrees about the x-axis. Pad the post clamp profile symmetrically along two sides. Groove the groove profile binder 360 degrees about the binder y-axis. Mirror pattern the pad and groove tool shapes about the base YZ plane. Create a subshape binder to the post clamp hole pattern sketch. Rotate 90 degrees about the x-axis. Pocket the binder through all. Create a new body for the M2 washer. Create a new sketch on the XY plane. Draw two circles coincident with the sketch origin. Apply distance constraints corresponding to M2 fastener head diameter and clearance hole diameter. Pad the sketch. Create a new body for the M3 washer. Create a new sketch on the XY plane. Draw two circles coincident with the sketch origin. Apply distance constraints corresponding to M3 fastener head diameter and clearance hole diameter. Pad the sketch.